Hello everyone, I am Priyanka Udge, working as an assistant professor at Walchand Institute of Technology, Solapur. And I am here to delivering the lecture on the topic DIAC Working and its VI characteristics. So these are the learning outcomes. At the end of the session, students will be able to explain the operation of DIAC, VI characteristics of DIAC. These are the contents: DIAC structure and symbol, VI characteristics of DIAC, advantages and disadvantages and applications. DIAC is a 2-electrode bidirectional avalanche diode which can be switched from on-off state for either polarity of applied voltage. So here 2 diodes are used in anti-parallel so that we have a in both direction, that's why it is called as a bidirectional avalanche diode. So we have a characteristics in both direction. The term DIAC is obtained from the capital letters diode that can work on AC. So that's why the name is DIAC. DIAC has a 2 terminals, that is T1 and T2. In case of a diode, we have a 2 terminals, anode and cathode. But in the DIAC, 2 diodes are used in antiparallel, so that here the 2 terminals name, that is the T1 and T2. This is the structure and symbol of the DIAC. In the structures we can see the 2 PN structure is there. Okay, so 2 diodes are connected in antiparallel, so at one time PN structure is conducting. This is the symbol of the second diagram, symbol of the DIAC, in which 2 diodes are connected in a antiparallel. This is the VI characteristics of the diode. In that, VBO is the breakover voltage, IBO is the breakover current, portion OA is the blocking state, portion AB is the conducting state, and in the first quadrant MT1 terminal will be positive, and in the third quadrant the MT2 terminal will be positive. Okay, so here we have to first apply the positive terminal to MT1 and the MT2 terminal will be positive in the third quadrant. So what will happen, at a voltage less than the breakover voltage, a very small amount of a current called leakage current flows through the device, which is produced by the drift of electrons and holes at the depletion region, is not sufficient to device on. Therefore, at that time the device is in non-conducting mode because the less voltage is there. So when this applied voltage reaches to the breakover voltage, the device starts conducting, means current starts flowing, and the current in the device that will be start increasing and the voltage decreasing. This portion is given by the line AB, known as a conducting state. We can see here this OA portion is the non-conducting and this AB is the conducting state. Here the value of the current corresponding to the point A is known as the breakover current. Similar characteristics we get in the third quadrant also, which is the replica of first quadrant characteristics. This is happened because of the doping level is same at first quadrant, doping level is same at the 2 junctions of the device. So in first quadrant MT1 is positive with respect to the MT2, whereas in the third quadrant MT2 is positive with respect to the MT1. So here one point is to be noted, the breakover voltage for commonly used DIAC ST2 is 30 volt. As the applied voltage is less than the 30 volt, the device is not conducting, and as we cross the voltage, means forward voltage, above the breakover voltage, then the device will be start conducting. So here DIAC is also used as a triggering device for the triac. So this is the VI characteristics of the diode. These are the advantages. It has a very small size and because of the cost is low. The symmetrical switching function of DIAC will be reducing the harmonic in the circuit applications. DIAC don't have any firing angle as it has a two terminals T1 and T2. No gate terminal is there, that is controlling terminal is absent. DIAC can be used in any direction if it is forward or reverse bias. So that's why it is a bidirectional. We can have VI characteristics in both the quadrants first and second, and during a positive and negative half cycles. It is reliable for low power applications. It offers smooth control as an electronic component. The switching speed can be increased or decreased with the applied voltage. DIAC component offers symmetrical switching characteristics, and at last it has a low on-state voltage drop. These are the disadvantages. As we have discussed previously, it is a low power device. It cannot block high voltages, do not have a control terminal, that is the gate terminal, only having the two terminals T1 and T2, low power handling capacity, and it can only conduct when voltage increases above 30 volt. These are the applications. So DIAC is mainly used to trigger various power semiconductor devices like DIAC SCR. It is also used as an AC switch as it can conduct in both directions. So we can have the output for the positive half cycle and the negative half cycle. It can be used in the lamp dimmer circuit. So here we can vary the AC phase. In that case, the DIAC is used as a trigger for the DIAC. So as the DIAC is triggered, then the DIAC will be triggered, and according to that we will get the output. Also DIAC is used in a heat control circuit and in the speed control of the universal motor. These are the references. Thank you.